Hey Larna, this is Miss Mo. Okay, for scientific notation, that's the one that looks like a number times 10 to some other number. Okay, and then standard notation just means whatever number they gave you. Maybe they gave you it with some commas, or maybe there was a decimal and then another number. Either way, standard is what you start with. Okay, so let's say I have 32 million. Let's say Earth is 32 million miles away from the sun. That's not a real thing, but just pretend. So let's say we got 32 million miles. If I want to take it to scientific notation, first I look for this number at the beginning. And this number has to be in between 0 and 10. Okay, so we're going to find where my decimal is right now. And my decimal right now is buried. It's pretend. It's right here at the end. Okay, and so now I'm going to count how many times I can move that decimal once, twice, until that decimal lands over here. And I need it to land so that the number I have is between 0 and 10. So let's see here. Let's keep moving it. I just moved it once, twice, 3 times, hits the comma. 4, 5, 6 hits the comma. So this is 6 movements. But look at the number that I have with 6 movements. If I put that decimal after the 32, it's still just 32. But I want a number in between 0 and 10. So I'm going to take one more swoosh. Alright. So now I see the number 3.2. So this first number you write down for scientific notation has to be in between 0 and 10. Okay. And it should be something like one number, decimal, another. So here, if I would have stopped moving the decimal, right here after the 2, that means I would have the number 32. But I need a number in between 0 and 10. So that's why I made another movement. Okay, so I landed at 3.2. Let's count how many times my decimal moved. 1, 2, 3, 4, 5, 6. And then I went another one, 7. And I moved that decimal 7 times to the left. Okay, so we're definitely going to put 3.2 times 10 and put a 7. Okay, and when this exponent came from a freakishly big number, or if you moved left, we use a positive exponent. So that 7 in the air happens because the decimal I had made a number bigger than 10. So I moved my decimal one at a time until I could get to 32. That's not in between 0 and 10. So I had to move once more. And I got 3.2. So I write 3.2. I don't write any of these zeros. Then I write times 10. And then that number at the top is how many times you move. Okay, let's do another one. Let's say we have this. We start with this number. Okay, well, that's a lot of zeros to write, and it's kind of annoying. So we use scientific notation. We're going to take the decimal that we see right here. It's on the different side, but it's okay. And we're going to move that decimal until we get to a number in between 0 and 10. So let's move the decimal. Once in between the numbers, twice, 3, 4, 5, 6. Okay, if I stop right here, then I have the number 0.32, and I don't want that. I want a number like a 5.6 or 8.9 or something like that. So let's move it once more. All right, and now we see we have 3.2, and let's count how many times we moved. I moved 1, 2, 3, 4, 5, 6, 7 times, but this time I moved to the right. Okay, so when my decimal moves to the right, you have to use a negative exponent. So this is 3.2 times 10, and we moved 7 times, so I put a 7 in the air. But because I came from a decimal, or because I moved my decimal to the right, to the right, to the right, I got to use a negative exponent. Let's do another one. Let's say I have 12,000. Just 12,000. Okay. Well, first I want to find the decimal. It's right here. Okay. And then I want to move that decimal so that it's in between these digits. Let's see. Move the decimal once, twice, 3 times. And if I just move it 3 times, I wind up with the number 12. I want a number in between 0 and 10, like 3.2. So let's move once more. Hey, there we go. So now I have the number 1.2 times 10. Let's see how many times I moved. 1, 2, 3, 4. I moved 4 times. And let's see which direction I moved. Where did my decimal start? Over here. And I moved it left to get 1.2. Okay, so left means use a positive exponent. So we put +4 in the air. All right, let's do different. Let's say we have 0.000000007. Okay, I just put some spaces in here, but it's supposed to be all squished together. I just put spaces so I could count by 3s, because I like to count by 3s. Okay, anyway, I need to end up with a number in between 0 and 10. So let's move this decimal, and it looks like I'm going to move it to the right, because it's on the left right now. So we're moving to the right. Let's see if we can count how many. 1, 2, 3. Then 4, 5, 6. Then 7, 8, 9. Then 10, and that gives me 0.7. But we want like some kind of whole number and then a decimal, like 3.2, 1.2. So I'm going to keep moving my decimal all the way to the very end, so that all I have is the number 7. And after that 7, it's kind of like saying, well, we'll just do it like this for now. Okay, so we moved right. Let's count how many. I forgot again. 3, 6, 9, 10, 11. Okay, I got 11. So I'm going to say 7 times 10 to the 11. And since I moved right, we got to use a negative exponent. So negative exponents in scientific notation come from decimals with a bunch of zeros. Positive exponents in scientific notation come from a number with commas and a bunch of zeros. Okay, let's, learn how to multiply. I think this is what you were doing, maybe. Let's say we have 8.6 times 10 to the 14th. And let's say I have to multiply that with 3.7 times 10 to the 3. And we have to multiply this. Okay, I'm not sure if you need this, Larna, but I'm still going to give it to you. So let's say we have to multiply 2 sets of scientific notation. The first thing you do is you multiply the regular old numbers. 8.6 times 3.7. Let's see what that gives you.